Section 4.5, Exponential and Logarithmic Equations. This is part 1. To solve an exponential equation, we have two methods. The first method, we're going to isolate our exponential expression. After we isolate our exponential expression, we have to think to ourselves, what undoes an exponential? What is the inverse of an exponential equation? The inverse is a log. So if I isolate my exponential and then I want to get rid of it, I'm going to take the logarithm to get rid of it. We'll take the logarithm of each side and we will use the same base. Then we're ready to solve. Okay, another way to solve an exponential equation is to write the bases so that they're the same. If I can write the bases so that they're the same, then all I have to do is equate the exponents. Okay, problem number 6. We're going to use the second method here because we can write the bases so that they are the same. This would read 10 to the 2x minus 3 is equal to 10 to the negative 1. In this example, we now have the bases equal. Because the base is equal, we can set the exponents equal to one another. 2x minus 3 is equal to negative 1. All right, this one we should know how to solve already. We'll start by adding 3 to both sides, so we get 2x is equal to 2. We'll divide both sides by 2, and so we get x is equal to 1. Now, when solving equations, the nice thing is once you have a solution, you can always check to make sure that solution is correct. Okay, let's check our answer really quickly. We have 10 to the 2 times 1, because we're checking to see that x is equal to 1. We have 2 times 1 minus 3. Let's see if that's the same as 1/10. You always plug your solution back into the original equation. Okay, so we end up with 2 minus 3, which is a negative 1. 1 over 10 is 10 to the negative 1. And so we know we have a good solution. Okay, next one. Find the solution of the exponential equation. Okay, so once again, we're going to rely on the second method of solving. Why are we relying on the second method of solving? It's because the bases can be written equally. They're already written equally. They're both base e. Because we have equal bases, we can set the exponents equal to one another. 1 minus 2x is equal to 3x minus 5. Okay, so we're ready to solve. I'm going to probably, and there's many ways to start out, what I'm going to do is I'm going to move that x over, 3x over. So that would give us 1 minus 5x equals negative 5. Then we'll subtract 1. So that gives us negative 5x equals negative 6. We'll divide both sides by negative 5. So x equals 6/5 is our solution. Now, if this were a test, we would want to check to make sure that is correct. We could check by putting it back into the original equation. But I'm pretty sure that we followed the correct steps, so I think we're going to be good. Okay, next problem. Find the exact solution. Use a calculator to find the approximate solution to 6 decimal places. Okay, so exact solution versus an approximation. The approximation is the one that we turn into decimal. Exact is going to be always what we report. The exact answer is always going to be the preferred answer. So we want to always answer exactly. Okay, can the bases be written in the same? Can the bases be written equally? Not in this case. There's no way we can make this 8 look like an E. So that second method is out. So let's look at the first method. We're going to isolate the exponential, already done. Now we're going to take the log of each side. Why are we taking a logarithm? We're taking the logarithm because it inverses or undoes an exponential. We take the logarithm of each side using the same base. So since this is e, we're going to use log base e, which is ln. We're going to log base e both sides. Okay, so let's ln both sides. So we have ln of e to the 0.4x, and then we have ln of 8. We took the logarithm of both sides in order to get rid of that exponential. So we end up with 0.4x is equal to the ln of 8. ln of 8 does not cancel. We can plug that into our calculator and get a decimal approximation if needed, but we're just going to leave it as is. All right, to move over our 0.4, since this is a multiply, to move it over, we're going to divide both sides by 0.4, and so we end up with a final solution. X is equal to the ln of 8 all over 0.4. This is the exact answer, and the exact answer is what we want to report. I don't know what's going on with the pen, but approximate answer, let's go ahead and put that into our calculator. So you're going to use your ln button, which we practiced last section. ln of 8 divided by 0.4 gives us, and they want 6 decimal places, 5.198604 to 6 decimal places. Okay, so we're looking at 5.198604. Okay, let's go to our next example, which there isn't one. That was the end of part 1.